Okay. All right. Vaibhav and Adesh, you're the only two guys here? Well, it's just 6 o'clock. We'll give them a few minutes, okay? Hey, Adesh, you should feel free to switch on your cameras. Someone else is here too. Everybody should switch on their cameras. Yeah. Who's that on the other side? So someone appeared and then just, oh, that was Mason. Mason, you got a, hey, Mason, you got a weird icon. It's like on Zoom, you have an icon. Is that right?
Oh
It looks
yeah.
like a switch.
It's a tank from a video game that a friend made.
Oh, yeah, yeah. Okay. Yeah. Okay. Yeah, that makes total sense. Yeah, I think I've seen that. All right. Great. Is that an ASCII character, by the way, or is it just you made a graphic and you're using that?
No, it's the player character from a game a friend made.
I see. All right, cool. Cool. Okay. Anyway, I'm just here for a very short while, okay? So I'll just leave the meeting with you guys in a little while. I'll stick around for about 5 or 10 minutes if you guys have any questions. And if other people have any questions, they can come and ask too. I'll be here for 5 or 10. Okay. And after that, you guys can run the meeting as usual, as before. I'll take off. Right. I'll also, if necessary, I can also attend next week before the midterm. But I don't think it's necessary. Unless you want me to attend. I don't need to attend next week, but you guys will be okay for the midterm. As far as the midterm is concerned, you got to the quests are not the focus on the midterm. The midterm will focus on the topics and concepts. And the topics are exactly the topics that are given actually we do have them in the modules, but all of the topics are in the textbook as well. Okay, so at some point what I can do is actually just extract a list of topics from the modules, just a list of topics, and put them in one of you can do that too, and put them in a Reddit post or in the or a separate post in the modules, because the modules could go away because of copyright issues and all. It's actually owned by Foothill, and I gather that it's not public domain. So I might actually take it out, the links out. However, if I make a list of the topics, that's all you need, because you just need keywords to search on internet, right? Because if you want to know about how do I do polymorphism in C++, okay, or polymorphism examples in C++, you just need to search. And well, the danger of just doing a blind search is that you'll get lots and lots of links, and it won't be sufficiently spaced apart, so you'll get too many things to cover. But if I give you a list of topics and you only search for those topics, that means that you're guaranteed a good path through the morass of information on the internet, because you'll do some, and then the next topic will be sufficiently detached so that the rest of it you can do on your own. That is, I think, the real danger of most people that are trying to learn on their own. The only thing the biggest risk they have is they won't. The odds are stacked against them for pacing themselves, because they have to judge. They have to judge how fast they're going based on their own talent, which is constantly changing because they're learning. But the amount of information is not scaled properly. It's given in certain chunks, and people say, oh, I got to cover a certain number of chapters every week, but that is not the way it works. If you cover a certain number of chapters, certain number of pages each week, you never get the essence of the book, I think. Anyway, so that's my 2 cents. Happy to answer any other questions if you guys have. Otherwise, I'll just take off and you guys can carry on as usual. And make sure to stay on top of the quests. Okay, I see many of you have been regular and questing along, and every day making a couple of maybe I'm going to make this announcement at some point, or maybe someone can remind me. Extensions are available to anyone who has put in consistent effort. What I mean by that is every day they try for a little bit and they get at least a couple of trophies every day. I mean, the whole quest is like 20 trophies or something. But if you keep trying, instead of jumping in the last couple of days or even 3 days before, saying, well, that's nothing at all, I can conquer it in 3 days. And then, and then if they get stuck at all, if they finish it in 3 days, okay, that's okay. But if they get stuck at all, they're not even getting help on Reddit, because everybody's probably done, or everybody's busy trying to crack it. And then they won't get an extension because they haven't been working regularly, right? So the odds are really stacked against them. So the best thing to do is to continuously keep working at it every day, just like music practice. You can't come to it once a week, and you got to do a little bit every single day. And otherwise what happens is that you are shortchanging yourself. See, what happens is that you make some progress, and then the next time you come back to it, you've gone back here. So you got to cover this ground again, and then go a little bit more and go back. However, if you figure it out, so every day I only need to do 1 hour, then you won't go from here to here and then go back here, but you'll go from here to here, but stay there the next day, right? And so you'll make consistent jumps. So you got to figure out that interval. And I think the an interval that works beautifully for most humans is 1 day. Okay, 1 day for most of the things that we do. Especially things that require practice, everyday practice. You got to do it. And it doesn't mean that you do 7 hours a week, like 7 hours 1 day a week. No, you got to do 1 hour each day, and that is like a lot more. So I got to make sure that point is in the syllabus from next quarter onwards. Okay, and I'll make an announcement later on, so people can get extensions as long as they are on the ball, doing stuff, helping other people on the Reddit and so on, because I know all of these things. And I follow these posts, and I look at your code and your submissions, and sequential submissions over many days too, right? I mean, I do have automatic stuff to monitor stuff and let me know, but even then, I go and take a look myself, and I can tell, right? So if someone's just coming in the last few days and trying to get through things, yeah, okay, they better get through it, right? Because they are so confident, and and because otherwise, if you want extensions, you got to be on it, I think. In 2A, maybe I don't matter. Maybe I don't care so much, because many of them are not like intending to specialize in CS. And, they are fringe subjects, and they want to get to know about CS before they go off into their own worlds. But 2B and 2C, we're talking about people who want to eventually become software engineers, or programmers in some capacity. Serious programmers. I mean, they can't afford to slack off at all, because that has got to be our bread and butter. You got to be thinking and eating and breathing it. Because otherwise you're not going to cut it out there. And so the best thing is to have a hard time in college, so you won't have a hard time outside, because your time in college is what, like 8 years at most, but outside your time is like 80 years or more, right? So you better to have your 8 years of hardship here and 80 years of happiness out there. So you got to really slog it out here, instead of just partying for 8 years and then having a really hard time later on, not being able to party afterwards. So yeah, that is my that's my fatherly advice to you guys. Okay, so but anyway, I see that you guys are doing good work, but sometimes I do see you disappear. Okay, just watch out for that. Okay, even now, right? Only 6 of you guys are here. Some people are not here, and many of them come in once in a while and disappear. That's all danger signs. Okay, danger signs for aspiring future software engineers. You can't take a break like that. Okay, this has got to be in the forefront of your memory, of your mind all the time. So these people have to take it seriously. But some quarters I have lots of students who are continuously engrossed and doing work. But some quarters, maybe it's fall, maybe it's a time of year, things like that. Because it also depends on what all the other departments and other people are offering, right? Because if you're after some really exciting courses in math, right, or maybe in theater or something like that, and they're only offered like once every year in the fall. Yeah, obviously, right? And so the fall hard courses in CS will suffer. So maybe it's because of that. But some quarters I actually do have students like you, many students like you guys, who are really committed and do it. So my hope is that we're not yet at the halfway mark of this quarter. I hope that everybody will get back on the boat, and you guys should do what you can to jazz it up and pull people in. Because you guys are on the boat, you got to pull more people into the boat, as it were. Okay, so you got to encourage other people. I know sometimes you make a post and nobody responds, and then it feels like a bummer, but it's okay. It's okay, right? It's don't make a post expecting someone to respond. Just make a post anyway, because it may be a killer post in terms of interestingness and nice things. Just go ahead and do the post. And people will join, right? More and more of these things, and also ask people in your other Discord discussions. I'm pretty sure students have these other discussions where they discuss quests. You don't discuss quest code in the Reddit, but you shouldn't really discuss quest code anywhere, okay? Whether it's a private forums, even SMS, or even across the table in a STEM center or in the library. You should never discuss code with your friends, quest code with your friends or your parents or relatives. Never and ever do that, okay? Because the whole idea of these quests is that you get an opportunity to work on your own. You can discuss other code, right? So if you say you don't, something doesn't work with pointers or trees, right? Make up your own problem with pointers or trees. Yeah, you can make billions of problems like that. Make up a tree, random tree, right? Make up a tree of CS2B students, or make up a tree of all of the people and your ancestry or something like that. Make up a tree and say, well, I'm trying to do this and it's not working. Right. And someone, I think Ryan or someone, I think it's Justin posted this visualization software, right? There's lots of very nice algorithm data structure visualization websites out there. Okay, I think Visual Go, I think that's the one that Justin posted. So yeah, okay, so you don't even have to create the graphic anymore. You create the abstract data structure, dump it, and then put it in Visual Go and take a look and say, well, you know what, and ask and pull in your relatives and your brother and sister and mom and dad and say, hey, I'm trying to do this, but maybe they're computer scientists, right? So you can tell them, I'm trying to do this, but I printed out, this is what I'm getting, what's going on, okay? So that's perfectly okay. The only thing you're not allowed to, even in math, right? When you're working on problems, I say, well, it's not like every problem should be, they encourage people to work at a table, together at a table so you can look at other people's proofs and all, but you're not really allowed to work on other people's proofs in a test setting or assignments. Assignments are supposed to be done on your own, but practice problems are supposed to be done together. Anyway, that's the general recommendation, which kind of works for math, and I'm pretty sure it also works for, computer science. General computer science problems, general algorithm problems, and you should feel free to talk to other people also, right? Yank them in, jazz them up, fire up the interest and curiosity in them and get them to work on this with you, because that'll also be practice for you later on, right? Eventually you're all going to be managers, and you got to be you got to fire up your engineers, okay? I can tell you that from back in my days when I was managing people, software engineers, I can tell you, you cannot get the best out of engineers unless you basically motivate them, okay? You can't whip them, you can't give them higher pay even. None of that shit works, okay? But if you're fired up about something, you can say, well, the company's going down the tubes, we're not going to pay you. And they'll say, oh, I'm still going to work on this anyway because it's really cool. Okay, so that's the kind of attitude you actually kind of develop on your own, because you're trying to find all these incredible things online, and you want to convince your people around you, right? Your friends, relatives, brothers, sisters, all of them. Say, hey, this is really cool, right? And I wrote some C++ or JavaScript or whatever it is, a Python code to do this, and it doesn't look like that. What do you think might be going on? Okay, and maybe it doesn't sound all that interesting the first few times, but after you try it out on 15 people, okay, 15 people, hopefully all friendly people within your social network and friends, right? And so they're not gonna say, hey, that's a stupid person for not being able to explain that. No, nobody's going to say that. But you try that among friendly people, and you'll find that your skills at explaining these things, what I mean by explaining is not just making the other person understand, okay? This is the first step. And you'll get good at that after the first, maybe a month or so. You'll be able to take a concept, explain it, and make that person understand, okay? But that is just the first step. But after you've got that, you're going to ask, okay, well, I've made that person understand it, but still they're not working on it anymore, right? After I can make sure they understand it, but they've moved on. So what? Because they've got other competing interests. Now you start thinking of how can I make this more interesting than all of their competition, okay? This is like thinking like an entrepreneur. That's really what it is, right? Because everybody has a killer idea. But the ideas that win are killer ideas that are also better than the competition. So a lot of people have to look at what the competition is and analyze the competition. However, as an inventor and an entrepreneur, that is the last thing an entrepreneur wants to do, right? When you discover or invent something, you want to believe that it is the best thing since sliced bread. Nobody's ever done something as good as that. So you got a mental block against even doing a patent search or doing online search, saying, has someone done something very similar? If I search for something like this, maybe the keywords will be picked up and someone will get the idea, right? All kinds of shit like that cram into your mind. So, entrepreneurs, innovative people, creative people don't like doing prior art search. Okay, and that is a nail in their coffin, because they could have a really good idea, but maybe they could have a better idea if they knew that this idea was worthless because someone else has done something very similar. However, we still, you can get the pleasure out of reinventing the wheel. But if that's what they wanted, that's fine. But most of the time, entrepreneurs say, "Well, I want the cake and eat it too." In the sense, I want the pleasure out of inventing this, but at the same time, I also want the commercial rewards that will come with it when people adopt it, right? So if you want that latter part, then you got to be really, really good at jazzing people up. And so you want to get to the next stage and say, well, you know what, now I've got the basic part out of the way, which is CS2A stuff, not in terms of entrepreneurship, right? So making sure that other person understands it. In fact, if you go to the top research institutions, they actively encourage researchers, scientists, and engineers from doing any kind of patent search. Okay, they say don't do any patent searches, because when I was at SRI, that's what they used to tell me, and I thought, initially I thought, that is bonkers. Why are they telling me not to do patent search? Because as researchers, you're supposed to do research. Okay, and so they were telling me that, and I did patent searches in the beginning. But it's after a while I came to the realization they weren't really helping me, because they're just holding me back, and saying, well, so they say, just go ahead and do it. Get the pleasure of doing it, because that's what you're being paid for. And if after you've done it, if it's really good and someone else hasn't done it, we'll take it and commercialize that. We'll file a patent and everything, right? So, and because that will not hold engineers and scientists back, saying, well, I got to search, because creative people just want to be creative, regardless of whether someone else has done it before or not. Yeah. So, letting our mind be cannibalized by thoughts about, has someone else done it? That is something that creative people don't want to do, but also, entrepreneurs have to do, unfortunately, right? So you can develop the skill of saying, well, you know what, I'm going to the first mile, which is knowing how to build a product. Now I'm going to go to the second mile after I know how to. You can't go to the second mile before the first mile. Okay, you got to do the first mile. You got to learn this stuff properly, right? It's all the way to Red Dog, right? And after that, you say, well, I've got the basic stuff now. I can build shit, right? But can I make stuff that is better than other things, that other people want to do this, rather than the competition that's, offers something that's vaguely similar, right? But, bug ridden or something like that, but I can do something much better. Okay. But you can't get to ask that question until you've mastered this. Okay. So you got to get there. But while you're doing this, you can anticipate that's going to come. Okay. After I master stuff, that is going to come. I don't want to wait until then to master this secondary skill. I'm going to start right away. So as I'm mastering this, I'm going to try and practice and hone my skill of trying to convince others that this concept is really cool. Okay. So this is, firing people up. Okay. And that is a skill. Some people, get it naturally, but you can actually train people to get it at, right? So if you believe that you can train yourself to fire people up, you've basically got a whole army behind you. Okay, so, and you can train yourself. It is a skill. So you just say, we'll start with Reddit. Okay, I'll start with my family and friends, and I've got a really cool idea. I got to morph this idea in such a way that it's applicable to them, right? And then explain it to them in their terms, and then try and yank them to look at the original problem in my terms. Okay, and say, hey, why do you think it's not working? Okay, that's enough. Okay, because that is enough to light the fuse in most people. Why do you think it's not working? Right? But in order for people to expose the fuse that says, why do you think it's not working? You got to do a lot of work. Because, otherwise they're not even going to say, I'm not interested in this problem. So you get them interested and then light the fuse, and then they'll take over, right? Meaning they're not take over from you, but they'll work with you. And so that is a trick. You can master that right away. Okay. Master that. Hey, Connor and Ryan, you should also, switch on your cameras. I'm going to take off right now, by the way. Yeah, I got about 5 minutes, but I'll take off. But basically, I just wanted to get that point across. All the other people are not here today, right? Many people are not here. Pass the message on. Pass the message on. Whatever other discussion forums you have, and tell them to come to these meetings, discuss interesting things, have their camera on, and also discuss other code in the Reddit. Right, in the Reddit, saying, well, it's related to something that we are supposed to do for the midterm, not even in the quest. Okay, in CS2A, take a look at CS2A. I think there's someone called Vivian one, right? She posted a piece of code which is not in the quest at all, and it's in the reading material. I'm experimenting with that, a variation of something in the reading material, right? And it's not working. Or there's something funny in here. Can someone explain what's going on? And that's all really cool, isn't it? It's not even connected, and you can do that in the Reddit. So pick up other material and experiment with it. And all said and done, right? All of these courses in college, they can teach you everything. Yes, nobody can teach you everything. What people do in college, especially as you ascend, go higher and higher in your education, they'll only give you a sample of what's available. Okay, and these samples are going to be further and further apart as you get better, bigger and bigger classes. Okay, so already in college, you're getting samples from here to here to here to here. Okay, a lot of stuff in between. You got to figure out for yourself. But a common misconception I find is that students just think that I just got to master all the samples and get through, and I get a certificate. No, we can teach you everything. The idea is that you know the whole thing, but we can't teach you the whole thing. So we give you some samples and say, all right, figure out everything else like that. Because I can't. Most professors can't teach you all of that. We're going to go to this topic now, right? So that means you got to pick up all of that yourself, and that is an opportunity for you to delve into the net, the textbook. A lot of sources, your classmates, your friends, even I've been talking to my cousin, and she came up with this interesting problem they're trying to do in her college, or at her work, and I came up with a way in which they could solve it. Can we take a crack at it, right? Or can you tell me why it's not working, or something like that, right? All of those interesting conversation starters. And it'll set the stage for you to just talk about computer science to other people without them even realizing that you're talking about computer science. Okay, so that is a beauty of a conversation, isn't it? Or a gifted conversationalist, right? They can talk about anything, but people don't even realize they're talking about a particular topic. Because it just relates to them anyway. So you will eventually figure out a way of talking about computer science to people, and they're figuring out computer scientific ways of solving things, but they don't even realize that. And that kind of happens in CS2A also, to some extent. Towards the end, people are saying most people start off new to algorithmic thinking or iterative ways of solving problems, but towards the end, they're actually coming up with some of these solutions themselves. So it's actually fun to see. So yeah, and it is good. They also say that it's very nice to find out that there's this really cool way of solving problems that you're not familiar with. One more tool at your disposal as a human being, right? So and it's really good to have that at your disposal. All right. Anyway, thank you all so much. If you don't have any questions, I'm going to take off. Okay. And I just wanted to stop by to ask if you guys had any questions, right? Yeah, and it looks like it's almost like 20 minutes, and I've been talking. So if you guys have any questions, I'm going to answer them. Otherwise, I will take off, right? And good to see you all. Okay, good to see you all. No. All right. Okay. All right, I'm going to take off. Feel free to discuss anything. Even code is fine. Okay, even code is fine. You can share your screen and share code as long as it's not Quest code. Okay, don't ask about Quest questions or saying, what should I do to get that extra trophy? That's all bad. Okay, don't ask that kind of question at all. But share code. I'm trying to do this thing, with binary trees or n-ary trees, and can someone code with me, or figure out what the hell is going on, and hit the run button or compile it and it's not working, right? What's going on? What does the error message mean? That's all, prime stuff for this kind of group. So you should absolutely take advantage of that. Okay. All right. Thank you very much. Hey, Connor, is your hand up, or are you just just like that? Okay.
Oh,
You don't
no,
have any
sorry.
questions? All right. Okay. All right. Okay. Thank you all very much. Noah, good to see you again. Jiang, Adesh, Vaibhav, and Mason. All right. Okay. I'll see you guys later. Bye. Best of luck for your midterm. Okay. Oh, Adesh, you got to be host. Is that okay?
Yeah, I can be host.
So how's everyone's questing progress now? Good. Did everyone pop quest 4?
I just like popping some of them, but I puked the Quest 4, but I keep getting like, you think that's it for like Quest 3 and Quest 4, and I don't know, kind of like don't know what's going on and still doing that. And I'm still kind of confused with how midterm is going to like what's the midterm gonna do because I'm late for this meeting. Like I don't know what guys are talking about. Like hey,
So the midterm just tests you on the C++ concepts and like data structure concepts that you learn as part of the quest or as like part of following the modules on Canvas. So it's not really anything specific about quests, it's just general knowledge, such as in the past, I've taken 2A, which is like introduction to C++. And some of the questions were like, it gives you a small snippet of code, and then it asks you what it does. And I'm not sure how different the 2B test will be, but I'd assume that it's somewhat similar.
so it's kind of like similar with like the concept question to like ask you what's the code to do, but it's not like about like debugging for a piece of code that shows in the midterm. Like is that just like I would say like multiple choice question with just filling up with the concept that just what the question asks. Is that similar with that kind of stuff or just like so I'm kind of like confused with like how this like computer science midterm gonna be like because it's not really like the physics or chemistry and yeah it's like I'm still confused like
I think as long as you know how to do everything in the quests and you're able to complete most of it, you should be able to pass the midterm pretty easily.
okay.
So the Quest 4 spec mentions that, so for Quest 4, we're implementing a general tree using a binary tree structure. And the spec asks if it's also possible to do this with just one pointer. And after giving it some thought, I think it is possible, but you have to store more than just a pointer. Where, like, if you had a node, you would have the data, and then the next node, and then also a optional piece of data about how far up the tree to backtrack. I think I might be able to describe it better if I share my screen. So yeah, node pointer to next node, and then we have the data, and then amount of nodes to backtrack. And then so the tree structure would look something like, if I go to here, so we have our root node, and then it goes down to here. So this is 1, this would be 2, and then this is like 3. And then if here we do amount of nodes to backtrack, let's see. If we set that to 1, then the code can go like back up to 2. and then down to the next node down here. And so we would be able to implement this with just one extra number on the node and then no extra pointers. But also, I feel like using this as a tree structure is not very practical or useful, since to get like, say I had also like nodes over here. To get to this node, I'd have to go through all of the nodes and all of this tree structure on our left hand side, even though what we want is like on the right half of a tree. So it's implementable, but I don't see a reason to use it, at least with this implementation. What do you guys think?
Is that like a forget what they call that, like a double-sided pointer, or where you can go forward or backwards?
Oh, like a double link list?
Yeah, yeah. Is that what you're trying to show? I'm a little confused.
Okay, so you've done Quest 4 already, right?
Yeah, I haven't looked at it in a while, but I think I'm pretty familiar with how it works.
Yeah, give me a second. So
What do we we're trying to traverse the tree.
yeah, so in Quest 4, what we did is, say we had this like general tree here, here, and then like this, here. And then we turned it into a binary tree where it would be, I'm gonna number these 2, 3, 4, 5, 6, and 7. So we turned this into like this, and then one of the pointers just goes to null, and then the other one goes to the child, which would be 2, right? And then here, the sibling would be 3 for node 2, and then the child of 2 is 5, or the first child of 2 is 5. And then we have like
Okay.
this goes to force, and so on. So we basically turn this general tree into this binary tree structure, where instead of each node needing like an unknown number of pointers to their children, we just have it pointers to the children and pointer to the next sibling. And so the spec was asking if it was possible to do this with just one pointer between nodes. And so I don't think it's possible to do with just one pointer without an extra data tag thing.
There already only one pointer between nodes.
Yeah.
So the general tree is where you have 2 pointers off of one node, right?
Well, the general tree would be you can have any number of pointers, or more accurately, any number of children under a node. Like, for example, here, node number 1 has 3 children, and then node number 2 only has 2, node number 3 has only 1, and then like nodes 4, 5, 6, and 7 all have 0 children.
Right. But how is the general tree different from what we made? I was pretty sure we just did pretty much the exact same thing, but just kind of thought about it differently.
Well, yeah, what we implemented was a general tree structure that, from the user's perspective, is just a general tree. But internally, it was implemented as a binary tree because our nodes only had a pointer to its child and a pointer to its sibling.
but isn't that like a binary tree?
So now the question is, if we can implement this general tree as a binary tree, can we implement it as a unary tree?
What is a unary tree?
So like, so pretend this is like the general tree. The actual like unary thing is just node 1 points to node 2, points to node 3, and then 3 points to 4. Well, if we want 4 to actually be a child of 2, we'd have to tell whatever is using our tree that 4 actually belongs one layer above 3.
Right. We'd
Yeah.
we'd have 2 point to 4. Right?
Yeah, it's a bit confusing.
What does he mean by one pointer? I think I gotta pull up the quest.
So yeah, like each in a binary tree we have the child and sibling pointers, and in this unary tree we would only have like a next node pointer.
Right. The unary is basically like a linked list. It
Yeah.
is a linked list, right?
Yeah, well,
If-
it is, but it looks like a list, yes, but we want to make it represent a general tree that the user can use as a tree.
How do we do that?
Yeah, that's
I
what.
have to go, but I'm gonna make Mason the host. Okay.
All right. Yeah, that's what I'm also trying to figure
Uh,
out. Right now, the idea is just. Yeah. Right now, the idea is to just tell it that, like, instead of node 4 being a child of node 3, it's either like a sibling of node 3, or like a sibling of node 2, or sibling of node 1, whatever.
okay, right. Because with the link list one here, we basically have 1 and then points to 2, which is a sibling of 1, and 2 points to 3, which is sibling of 2. So we basically only have the siblings.
Yeah.
I don't know how you could make the pointer point to something else with, like, I keep thinking of making another pointer.
Yeah, it's a bit of a difficult problem. I guess I'll think
Same
about it more, and then if I do come up with something that works, I can like make a post on the Reddit.
Yeah. You could change you could change the pointer and have the pointer point to, just change what the pointer points to. Like make 1 point to 3,
You mean like
and then yeah, like that. And but not, that's not a different pointer. You just now 1 doesn't point to 2 anymore. Okay, right, like that. So now 1 points to 3. And but then 2 also points to 3.
well like this like this is our do different colors. This is our general tree that we want to like show. And then so like
Right.
I'm gonna call this 5. So like 1 is the parent of 2 and 5. 2 and 5 are siblings of each other. And then 2 is also the parent of 3 and 4. And we have to somehow represent this.
I mean, you could have um
How about, let's see, let's erase all of the links for now. And then I'll go through like my current thought process, which is basically we look at the tree, right? So 1 has 2 as one of its children. So like 2 has to get pointed to by 1 somehow. So we'll just have
Yeah.
1 point directly to 2 for now. And then similarly, 3 is like the leftmost child of 2. So we'll have it point here. But now what about 4? We also want 2 to point to 4, right? But we can't just do a pointer here. And
yeah, no.
right now in our chain, 3 is the only one with like a empty pointer slot. So we kind of have to make it point to 4.
Oh, okay.
So we need to signal that this pointer is actually not a child. But instead it's like a sibling. Remove this. That's not working.
You could have like a true false indicator.
Yeah. Cover that up. Cover that up. Okay. So yeah, so 3 has to point to 4, but say that it's a sibling. Well, also we have the problem of 4 is the only thing that can point to 5. But like 5 is a sibling of 4's parent.
Right. Maybe because normally with a binary tree, the leftmost node has to be larger than the one above it. And or wait, no, I think it's the leftmost node has to be, it was either larger or smaller. Yeah, the left node is larger and the right node is smaller.
Wait, what does like larger and smaller mean?
Just the value. Like you did 1 points to 2. The 2 is larger than the 1. And so if this was a binary tree, like in the general tree structure, if you had a right node, that would be smaller. Yeah, that would be smaller than the node above it.
So you're suggesting that we figure out where a node goes based on its data value, basically.
Yeah. Like, because our 1 is our smallest value.
Mm-hmm. Yeah, I guess that works for specific trees that are set up to have like larger value this way.
Yeah, with the way we implemented it uh in the quest, we didn't really do it like that because they were all strings.
Yeah. The quest was basically like the data, the tree structure itself doesn't care about the data. It just needs to hold the data in that specified tree in like that shape.
Right.
So yeah, this is why
I
I
mean,
thought we should add an extra thing to the node to track where to go.
all right. How would we? How would maybe we'd have like a true false value that if it was true, then you would then it would indicate that it was either a sibling or a child.
I mean, yeah, that works, but then what about the 4 to 5 situation where 5 is not a sibling or a child, but it's like the parent's sibling?
Right. It's like all the way over there.
Yeah.
Um, okay, amount of nodes to backtrack. So you're saying we should just go all the way back to one. Oh, wait. Yeah, why couldn't we do that? Or wait, no, one can only point to one thing.
Like, so in our actual like data structure, 4 still points to 5, but then if the user wants to use it as a tree, then we treat 5 as a sibling of 2.
If I didn't quite get that.
Um, okay, yeah. I think I should think about this more because now I'm a bit
Yeah,
confused.
that's kind of hard to figure. I've
Yeah. Um, do you want to discuss a different problem for now and come back to this like sometime later?
Sure. You know, I was having a little bit of trouble understanding the one parent atomic automation on the Maya one. I did the quest, but I don't know. I'm still a little confused by how it works.
So one parent one.
Yeah, like when you only have one parent, so you start out uh with one bit for your current generation.
Yeah. Well, so like we have say 1 bit here, right? And then if it's one parent, then this cell looks here and it doesn't look at this. So depending on your rule set, say like our rule set is down here, where if we have a toad shape, then the next generation is a filled. If it's empty, then the next generation is also empty. Let's pretend this is our rule set, right? So then when
Yeah.
we're calculating,
Yeah,
is
no, I understand.
okay. So then which part?
Okay, so for one parent, we're only gonna have rules from, I think it's like 1 to 4, right? Or they're only rules that will apply, right? Because there are only that many
Combination.
different variations of bits
Yeah.
for the rule to be made, right?
Mm-hmm.
Okay. So you start out with one bit and you have to compare, say we had rule 1. So you would have, for the rule vector, you have just 0 and 1, or 1 and 0.
Wait.
I'm a little confused how it how I don't know. I don't know how the one the one it turns into the next generation basically.
Okay, so I'm pretty sure we're supposed to treat the rules vector as basically a lookup table. The way I implemented it is, so for like basically if it's one parent, we just look at the one parent, and then we treat it as a binary number, and we use that number to look up the corresponding entry in the rules table. And then for free parents,
Did you oh, you turned it into a binary, as in one would be still one, it would be binary one, it would be 0 1, right?
mhm.
Okay.
Yeah, so like one would just look up the, like, this is the 0th entry in the rules table. This is the first entry. Or like the
Mhm.
index equals 1. And then here, right, our parent is 0. We treat this as a number. Okay, still 0. And then here, this is a 1. So we treat that number as a 1 as the index. And then we look here, 1 is also blank, and then this is blank, and so on. And this method just works out, even for like 3 parents, 5 parents, stuff like that.
You because in the rules you have two rules you can compare. It's either 0 or 1, right?
Mm-hmm.
Your rule vector will be 0 or 1. And so when you have one parent, you're gonna take that one bit and convert it to a binary number, which will be 1. And which of the two rules do you look at?
Well, you look at the rule with the index of 1. I mean, this is like assuming the rules table is set up this way by your code. Well, I think the spec makes you set it up this way anyway.
Yeah, the rule vector was like I don't know, it was like inverted for me. Yeah, but they made you it would make sense to me that the rule vector would have 4. Oh, actually,
Well, it's 4 combinations because, like, basically for this result, we can either have a filled in or not filled in. This is like two possibilities, right? And then we have another can be filled in or not filled in. So 2 times 2 equals 4. And then if we have 3 parents, then that would be 2 to the 3 equals 8. Possible combinations of parent pairs. And then for each of these
Mhm.
parent pairs, the result can either be a 1 or a 0, right? So that would be like 2 times 2
Right.
times 2, 8 times. So 2 to the 8 equals 256. And then,
Right. Okay. Yeah.
but we only have like 8 actual entries in the rules vector. But 256 different combinations that we can put inside that vector.
So equivalently for the one parent, we will only have 2, not 8.
Well, we have, this is the number of parents, right? So then 1 parent equals 2, like the rules vector is size 2, and then 2 to the 2 equals
Mhm.
4 possible rules that we can select.
Okay. Right. But for from what I from the test grader thing, it's basically telling me that if you get you have one parent and then it should turn the next generation into a 0. I can't remember which rule it was. But I'm just confused by how exactly.
Well,
I knew this at one point.
would you remember the rule that was specified?
Rule 1. Let's just say it was rule 1. How would you it was automation 1 1. Like rule set 1 and
Number of parents.
number of parents being 1.
Okay, so let's define our rules table here on the side. Oh, how to interpret the rules. Hold on. So, wait, what was that? So, if a parent is empty, rule 1 says that. Give me a second.
I get you can bring up the calculator actually. You bring up the calculator and go in the programmer. Rule 1 should be, I think, 0 1.
0 and then 1, like that.
Why do you have 4 blocks?
Well, this would be like the parent, right? And then this is the next generation.
Okay, right.
So then the actual like rules vector is just this thing. And then the top part is just for clarity. Let me see. So if rule is 1, wait, if rule is 1, I think it's this, and then this is blank.
Wouldn't that be 2? Because in bits, if you count up in bits, then the leftmost it goes 1 is 1, 1 1 is 2, 0 1 is 3. So this would be 3.
Well, yeah, but then the rules vector was
Or that
specifically
would be 2.
defined kind of backwards.
Yeah, okay, right, yeah.
Yeah.
So yeah, okay, no, right. So this is 1. So index 0 is on the left.
Yeah, so basically this just inverts whatever was there. Like first generation is like this, second generation It's just everything is filled except for the one that was previously filled.
So if it was a 1, you would make it 0. If it was a 0, you would make it 1. How would that? How would I don't know why the one parent just doesn't like something about it. Just not quite getting. Did you append the one the 0 bit next to the 1?
Wait, what do you mean?
Well, because you start out with current generation would be just a single one bit within your vector.
Mm-hmm.
And so you have on this top part, you have as an empty block and a filled block.
Yeah. Wait, are you referring
So
to?
the filled block would be the 1. Yeah.
Yeah. What is the one?
So did
then
you
this
like
would
when it comes to, I'm sorry.
So basically, if this was our current, right, then the next generation would basically depend. Like, so for this cell, it's white. Current is white. We look down, it should be filled now. And then this one is filled, and this is our current. Look here, look down, and it is blank. So we make it blank. And then we repeat.
But when we try to like because you only look at one rule, we have 2 rules within our rule vector. We take the our window, and compare it with our single rule.
I
And
mean,
if
like,
the rule,
how do I explain
because
this?
that's how I solved it. That's how I solved it with the 3 parent. I took the 3 in the window, and I compared it with the 3 in the 3 within the rules. And if the rule vector was true, then I would make it a 1.
Well, yeah, it's kind of like a, what was it called? Forgot what this type of function is called in math, but like basically this, where basically we pass the function r with x, which is like our current, the current parent that we're looking at, to determine the next generation. And then this rule function tells us that if the current is off, then we turn it on. If it's on, we turn it off. Then we just take the result of this mathematical function and we make it like the cell for that next generation. So basically, there's kind of 2 rules,
Yeah.
but they don't contradict each other. Because like if we say, if we blink out, give me a second. If we blink out this rule, and then we try to look at it, right? If x is blank, we make it filled. That's fine. But now if it's filled, this condition is not satisfied. So then we don't know if it's a 1 or 0, unless we have our second condition.
Unless we have our second condition. Oh, no. Uh, because, hmm. I mean, why is it with one parent we look at both rules, but with three parents we only look at one?
Well, no. I mean, with three parents, we have 8 different rules that we look at, and each of the rules
Right.
specify an outcome for that specific set of like parents there are. If I can extend this canvas, I should get something better than paint. But basically, say we had here, so we have our rules vector for the three parents thing.
Yeah, like 111, 101.
And then
Uh,
our like output box for each of these, right? And then
okay, yeah.
this is like all blank. This is one parent. This is like that. And then
Hmm.
so then when we have a so like say we're up here, we want to determine this the result of like this cell. Then we look at these three parents.
Okay.
And then so
Right.
say we had these three parents, copy it, and then now we drag it down and we try to match it with one of the things in the rules. And then
Yeah, so that one, so if that one is
And then-
false, then it would not match.
yeah, but basically if it matches, we take this and then we move it up here. And then that is now the value.
Yeah,
The
I
new
totally get three parent, but I don't get one parent.
I mean it's a similar thing, right? We take this, which is the only parent we look at. We go here,
Uh-huh.
and we go, does this match? No. Does this match? Yes. And so wrong select. Then we take this, and now it's the child.
Oh, dang. I guess that's when you explain it like that, it seems really simple. I don't know why. Yeah,
Yeah, it can definitely get confusing.
yeah, that makes perfect sense. I don't know why. I don't know what I was getting confused with. Did you have anything that you were confused with on the quests?
Not really. Not right now.
Did you make it to the the fourth one?
Yeah, I got the password for it, but I haven't finished all of the mini quests yet. I've just been kind of busy this past week, so
Yeah.
yeah. Well, I guess I'll see you next week.
Yeah.
Bye.
All right. Bye.